So for trinomials, we have the word tri, or the prefix tri. So tri tells you 3. So you're going to have 3 terms today, like 3x squared minus 5x plus 2. That's 3 terms that have 1, 2, 3. So it makes it a trinomial. Okay. So yesterday we were looking at binomials. Today we're looking at trinomials. All right, so for prior knowledge, I'm asking you guys to find the area of each rectangle. So for area, how do we calculate the area of a rectangle? Go ahead and write it to your partner. Try to see if you remember how to find area. What do we do to find area? All right. So for area, what do we do, Aaron? Length times width? Carlos, what'd you guys say? How to find area? Thank you. Jasmine, how do we find area? Where's Jasmine? You don't know? Lupita's not here. Snow, how do we find area? Okay. And Jose, how to find area? Medina? Oh, you're Medina. Okay, my bad. Length times width. So I heard length times width times height. And I overheard people saying you add up all the sides. So perimeter is when you add all the sides. Length times width times height, that's volume. So for area, it's just length times width. Okay? So to find the area for this first example, you're going to take the length times the width. So like 3 times 5. And then figure out what would that be. For the middle one, what's the length times the width? Well, you would do 2x times 3x. Multiply them and figure out what you get, and so forth. Try to see if you can find the area for all 3 of those. Okay, lefties, tell your partner, what did you get for all 3 of your areas? Okay, ready? So for the first one, what did you get, Richie? You know what 3 times 5 is? 15. So our area is 15. All right, for the second one, Fatima, what did you get for your area for the second one? 6x squared. 6x squared, thank you. And then for the last one, Maddie, what did you get for the last one? Negative 5x, thank you. So that's the area for all 3 of those. So today we're going to be looking at area models, which is why I wanted you guys to review that in the prior knowledge. We're going to get something that looks this looks super complicated right now because there's a whole bunch of stuff on the slide, so don't freak out, but it's just everything is broken up step by step, okay? So we're going to be factoring trinomials today. Let me switch color really quick. So to factor trinomials, we're going to be looking at the 3 terms. So in order to factor, you want to find A, B, and C. So that's our step number 1 is find A, B, and C. So if you remember, A is like the coefficient in front of the x squared. And then the B term would be the one next to the x term. And then your C term would be the one at the end, the coefficient, okay? That's how you find your A, B, and C. So A is 2 in this case, B is 3, and C is negative 14. Okay, so that's step number 1, is just being able to not calculate, but determine what those 3 values are. Okay, then for step 2, you want to figure out the sum and product. Let me switch color again. So step 2 is find the sum and product. So you want to find the same 2 numbers that will add up to your B value, and they need to multiply to your A times C. So in this case, the B value again was a 3. So they need to add up to 3, and then they need to multiply to A times C. So the A value was 2. The C value is negative 14. So if you multiply those, you get the negative 28. They have to multiply to negative 28 and add up to 3. So those 2 numbers would have been like a 7 and a negative 4. 7 plus negative 4 gives you positive 3, and 7 times negative 4 gives you the negative 28. Okay? So then I'm going to take those 2 values, 7 and a negative 4, and I'm going to put them inside of my area model. So for step 3, I'm going to put everything inside of the box. So for my first box right here, I'm going to put whatever the first term is. So that's the ax squared. So I put the 2x squared in the front, the first box, okay? And then the negative c goes in the other diagonal box over here. And then the 2 middle terms, the 7 and the negative 4 that I got right here, I'm going to put them in the other 2 boxes.
Teachers, if you have students with passes for the hearing band, please release them now.
Okay, so that's how you set up the box. So first, it's whatever the A value is up here, the 2x squared, that goes in the first box. And then our C value goes in the last box. And then whatever you got for those 2 values that multiplied and add up to those 2 numbers goes inside the other boxes, along with an x. Because the B value has an x, then those 2 values need to have an x as well. Okay? And then step 4 is to verify that the area of the rectangle matches. So like a 2x times an x would give us a 2x squared. 2x times a negative 2 gives you negative 4x. And then a 7 times x is 7x, and 7 times negative 2 gives you negative 14. Okay? But how do we actually get those values? Is looking at GCF. So if I look at this first 2 boxes, I'm looking for the GCF between a 2x squared and a negative 4x. What would be the GCF? Well, the GCF is 2x. Okay? And then once you get the GCF, you look at like 2x times what gives you a 2x squared. And then a 2x times what gives you a negative 4x. And then an x times what gives you 7x. And then the last 2 corners should multiply to that negative 14. And then once you have all of your values, you're going to take these 2 terms right here. 2x plus 7 is your first binomial. And then x minus 2 becomes the second binomial. And you just put them together. Okay? And I know you're probably like way lost right now, so let's just look at an example. But for the concept, these are the steps we have to follow in order to factor trinomials. You want to first find the GCF between all 3 terms, and then you want to factor out into 2 binomials using the product and sum if possible. So for the 2 binomials, you want to use area models in order to find your 2 binomials. And then you want to check to see if you have any difference of 2 squares, your dots, like we did the past 2 days. Okay? All right, so go ahead and copy the first example so we can do one together. We have a 4x squared plus 2x minus 12. You need to copy it down. All right, so step number 1 is to find a GCF. So if we look at all 3 of those terms, is there anything that I can divide all 3 of them by? Well, I see they're all even, right? They're all even. That means I can take out a 2 from all of those. Okay, so I'm going to take out my GCF of 2 and see what you have left over. So 4 divided by 2 is going to give us what? 2. And then I'm left with the x squared. And then 2 divided by 2 is 1. So I'm just left with x. You could put 1x if you want to, but I'm just putting x. And then negative 12 divided by 2 would give us a negative 6. Okay, so the very first thing after your GCF is to go calculate your A, B, and C. Not calculate, but just determine what's A, B, and C. In this case, remember, A is whatever is next to the x squared term. So A is going to be a 2. A B is whatever is next to the x. So if it's not there, remember that's implied to be a 1. And then our C is whatever's next or at the end of the constant is negative 6. Then once you have your 3 values, A, B, and C, you want to figure out what 2 numbers would add up to your B value and what 2 numbers will multiply to A times C. Okay, so for the first one, it has to be B, and then for the second one, it has to be A times C. So what is my B value? 1. And then A times C, I'm taking the 2 times negative 6 is going to be negative 12. So what 2 numbers multiply to negative 12 and add up to 1? So you want to find the factors of that negative 12. So factors of 12 are like 1 and 12, 2 and 6, and a 3 and a 4. And they have to add up to a positive 1 because that's a positive 1. Which of these 3 pairs can give me a 1? The 3 and a 4, right? So I'm going to pick this 3 and the 4, but one of them has to be negative. 3 and a 4. One of them has to be negative because that 12 is negative. So which one would give me a positive 1? Negative 3. So because it's positive, I want my bigger number to be positive. Okay? So I'm going to need those 2 numbers that we just came up with, and then I need to figure out my my area model. So the first one is that 2x squared goes inside the first box right here. I'm going to put my 2x squared inside that first box. And then my C value, the C, which is negative 6, goes in that last box right there. And then for your 2 other ones, you're looking at whatever these 2 numbers were, negative 3 and 4. And then I'm going to check what this is. That's an x. So I need to put a negative 3x and a positive 4x. Okay, once you have your values, then you're going to go use the area model to calculate the GCF and then what goes on the edges of the boxes. So first I'm going to look at the first column. Between a 2x squared and a 4x, what would be my GCF? What do they have in common? 2x, right? They have a 2 and an x in common. So that goes at the top. That's my GCF. Then I want to use the concept of area to figure out what would go on the other side. So a 2x times what would give you a 2x squared? Well, I already have a 2 and I have one of the x's. All I'm missing is that squared right there. So to get the squared, I need to multiply by an x. So now I know that 2x times x would give me 2x squared. And then for this next side over here, I need to figure out 2x times what would give us a 4x. So I need a 4, that's a 2. So 2 times what would give me a 4? A 2. And I have an x. I don't need any more x's, so it's just a 2 on the side. Then for the other one, I'm trying to match it to a negative 3x. So x times what will give me negative 3x? A negative 3. I'm going to put up here a negative 3. And then just double check. Does 2 times negative 3 equal negative 6? Yes, it does. That means that I did it correctly. So for my two binomials, I'm just going to take this term up here, 2x minus 3, and put it into a binomial. So 2x minus 3. And then the one on the side, x and a positive 2. So that's going to be an x plus 2. And that's my final answer there. All right. Let me actually zoom in this one. Very small. Okay, let's go ahead and look at the next example. Go ahead and copy this example for us. We got a 3x cubed minus a 5x squared minus a 2x. All right, so for this one, we got to figure out what's our GCF here. So what can I divide all three terms by? An x. Good. They all have an x in common. So I'm going to go divide by x. So all three of those. I'm going to take out my GCF of x. Did I zoom in? Did I zoom in too much? Now you can't see. Okay. So I'm going to factor out an x and see what you get. So that 3x cubed divided by x, the 3 stays the same. But my x is going to become an x squared because 3 minus 1 gives you 2. Minus 5. And then x squared divided by x is going to give us x. And then for the next one, it's going to be a negative 2. Negative 2x divided by x. The x's cancel, so you just get negative 2. Then we want to figure out what are a, b, and c. Can I have lefties tell your partner what are a, b, and c? All right, can I have, on a count of 3, tell me what is A. Ready? Tell me in 3, 2, 1. And B in 3, 2, 1. And C in 3, 2, 1. Negative 2. Good. All right, then I have to figure out my sum and product part of it. So what two numbers will add up to your B value? And the same two numbers have to multiply to a times c. So I think lefties just shared, right? So righties, what would be the two values that they have to add up to and multiply to? Righties? Tell your partner what goes inside, or not inside, but what would those have to equal? Okay, ready? So what value do they both have to add up to, Jose Gonzalez? Okay, good. They have to add up to -5 and multiply to -6. Do you guys all know how to get those two? No? Some of you say no? So remember this first one, to add up to, they have to add up to b, and then they have to multiply to a times c. So the b value is -5, and then a times c, that's 3 times -2. That's how we get our -6, okay? All right, so then think about the factors of -6. Well, the factors of 6 are 1 and 6 and 2 and 3. I can get a 5 from both of those, but notice the 6 is negative. Because the 6 is negative, that means one of your two values have to be negative. If I do the 2 and the 3, that'll be a -2 plus 3 gives me 1. Or 3 minus 2, I just said that. 2 and a -3 will give me a -1. So I can't use this one because I can't get a 5 out of it, but I can use a 1 and a 6. One of them has to be negative. Which one has to be negative? The 6. Good. The 6 has to be negative because the 5 is negative, which means the bigger one has to be negative. Okay? All right, then for my area model, I'm going to take my first term right here, 3x squared. That goes inside the first box, 3x squared. And then my c value, the -2, goes on the edge over here, -2. Or I should say like on the other corner. And then for my two middle terms, in first period, a lot of people messed up on those first two boxes. So I want you guys to have a conversation with your partner. What would go in these two boxes right here? Go ahead and write it. No, lefties, share with your partner. What goes inside those two boxes? Okay, ready? So what goes inside those other two boxes right there? Hannah? Okay. 1 and a -6. What else is missing? What else did I put? An x. We got to put an x. 1x and a -6x. If you flip those, put them in opposite, that's totally fine. You'll just have it set up a little bit different with the GCF, but you can do it both ways. I'll show you both ways in a second, okay? So then the next thing you want to do is factor out the GCF. So between the first two right here, the first column, what is the GCF between a 3x squared and a -6x? I can take out a 3 from both of them and an x from both of them. And then for the one on the edge right here, 3x times what will give me a 3x squared? I already have the 3 and I have one x. All I'm missing is the squared. So to get the squared, I need an x right here. So 3x times x will give us a 3x squared. And then for the one on the other side, 3x times what would give us a negative 6x? Negative 2. Because it needs to multiply. 3 times negative 2 is negative 6. And then for this one over here is x times what gives you 1x? 1, right? So I need the 1 up here. And then just double check. Does 1 times negative 2, does that equal negative 2? Yes. That means you did it correctly. So then just write those as binomials. Take this 3x plus 1 times an x minus 2. So you just create a binomial from the two edges, okay? I wanted to show you really quick that if you do the 1x and the negative 6x on opposite boxes, you still get the same answer. So if I still set this up as a 3x squared and a negative 2, and if I switch this to negative 6x and an x, you'll get the same answer. You'll just start off with a different GCF. So if you get something like this, between a 3x squared and an x, what is the GCF there? All I can take out is an x. And then you think of x times what is 3x squared? Well, I need the 3x. And x times 1 gives me x. And then 3x times negative 2 gives you the 6x. And then negative 2 times 1 is still negative 2. So if you notice, I still got the 3x plus 1 and the x minus 2 there. The only difference is your binomials kind of just switch to the opposite side. The lengths and the width change, but you still get the same answer. So it doesn't matter for the middle term where you put those two boxes there, okay? All right, so this one's a practice problem. Can I have you guys try this one? 10x squared plus 28x minus 6. So this is a practice. You guys are trying this one? All right, so here's the solution. You guys should have had this here. Double check your papers. For this, you can take out a 2 from all of those. So because you can divide by 2, your GCF is 2. And so then if you divide 10 divided by 2, that gives you 5. 28 divided by 2 gives you 14. And negative 6 divided by 2 is a negative 3. So then our A here was 5. B was 14. And then C is a negative 3. So your two numbers had to add up to 14 and multiply to negative 15. So those two values should have had 15 and a negative 1. So when you set up your boxes, your 5x squared goes in the first box here. And then that negative 3 goes in the other corner. And then your two middle boxes are whatever these two numbers were with an x. So a 15x and a negative 1x. And then you look for GCFs. Some of you, I know, did it the opposite way. Like you put the 15x and the negative 1x flip. That's fine also. So in the first box, what's the GCF? Well, you have a GCF of x. Or if you do it this way, the GCF is a 5x. And then just multiply your area models and you will get 5x minus 1 and an x plus 3. If you notice for the answer, it has a 2 right here in the front. Where does that 2 come from? That 2 is the GCF. In the last two examples that I did, I completely forgot about the GCF. You want to add the GCF to your answer. So can I have you guys go back to the last two examples that we did together? For this one, the GCF was x. So I need to add x in front of my two binomials. I completely forgot about the GCF. I apologize about that. Your GCF should be attached to your answer, okay? Likewise here, for the first example, GCF was 2. So I got to take that 2 and add it to my answer right here. So it's 2 times a 2x minus 3 and an x plus 2. So make sure you always put the GCF in your answer, okay? I completely I blanked out. I completely forgot about it. Okay. Let's go ahead and try another example together. Go ahead and copy this one. 3x to the 4th minus 8x cubed plus a 4x squared. All right, so for this one, what is our GCF here? What can I divide all three of those by? 3 doesn't go into 8, so I can't divide by a constant, but they all have a x squared in common, right? So I could divide by an x squared. So in this example, the GCF is an x squared. That's going to be a 3x to the what power? Second minus 8x plus 4. Okay. All right, then our A, B, and C. A is what? 3. B is negative 8. And C is positive 4. So let's look at our product and sum. What do they have to add up to? What do the two values have to add up to? Negative 8. And what do they have to multiply to? 12. 3 times 4 is 12. Good. A times C gives you the value they have to multiply to. So then again, look at the factors of the multiplication term. The factors are 1 and 12, 2 and 6, and 3 and 4. So out of all three of those pairs, which one can I get an 8 out of? 2 and a 6, right? I can get an 8 from a 2 and a 6, but notice the 8 is negative and the 12 is positive. To get a positive, I either have two positives or two negatives. But because the 8 is negative, that means both terms should be negative. Okay? All right, can I have lefties? Well, how about you guys fill in the box really quick? Maybe I should split it up. Lefties, tell your partner what goes in these first two boxes right there. The two corners. Lefties? Okay. So, on a count of 3, tell me what goes in that first corner box. Ready? Tell me in 3, 2, 1. Anybody? 3x squared. Okay. And the other corner, what do I put? Tell me in 3, 2, 1. 4. Good. So that came from the first piece, 3x squared, and the constant part. Okay. Then you take the b value, these two right here, negative 2 and the negative 6. And look at the b value has an x. So I got to put a negative 2x and a negative 6x. Okay. All right. Then for my GCF part of it, 3x squared and a negative 6x. What's the GCF there? 3x. So 3x times what gives you 3x squared? X. And 3x times what is a negative 6x? Negative 2. And then x times what is a negative 2x? I'm missing a negative 2. And negative 2 times negative 2 gives me a positive 4. So now I have my two binomials, 3x minus 2 and an x minus 2. So 3x minus 2 and an x minus 2. But don't forget your GCF like I've been forgetting. Don't forget to put this x squared in the front right here, okay? Because the GCF was an x squared, you have to make sure to add that to your answer at the end, okay? Okay, I don't think we're gonna have enough time for another example, so I'm gonna go ahead and stop there for your homework. You guys are doing, I think there's only like 6 problems maybe, so it shouldn't be too bad for you guys, okay? All right, can I have you guys please help me sanitize the desk and go grab a paper towel, please, to wipe down?